Assume that a random sample is used to estimate a population proportion P. Find the margin of error E that corresponds to the given statistics and confidence level. So we're told that N is 550, X is 385, and we have a 90% confidence level. Now, if we find the z-score associated with a 90% confidence interval, we'll find that it is 1.645. And we can do that using statcrunch. If we look at what a curve looks like where 90% of the data lies between some value z sub alpha over 2 and its opposite minus z sub alpha over 2, what we would find is that 0.05 of the distribution lies in each tail. So that sum would be 0.05 plus 0.9 plus 0.05. That would give us our 1 or 100% of the entire distribution. And if we were to look up this z value, we'd find that it is 1.645. Now, in order to calculate the maximum error of the estimate, or in other words, the margin of error E, we would use the formula z times the square root of PQ over N. Now, P is X over N. So that would be 385 over 550, which in this case will be 0.7. Q is 1 minus P, so 1 minus 0.7, which gives us 0.3. So our margin of error, E, we'll find by multiplying 1.645 times the square root of 0.7 times 0.3 divided by 550. And that value then is going to be 0.0321 when we round to 4 decimal places, as specified in the problem. Assume that a random sample is used to estimate a population proportion P. Find the margin of error E that corresponds to the given statistics and confidence level. The margin of error is just half of the interval width. When we construct a confidence interval about a proportion, we find the sample proportion, which is X over N, and then we add the margin of error to it and subtract the margin of error from it. And then that gives us our interval endpoints, which would be P hat plus the margin of error and P hat minus the margin of error. So what we'll do is we'll use statcrunch to help us find these interval endpoints. We'll subtract them and then divide by 2. So we go to statcrunch, stat, proportions, one sample with summary. The number of successes, we're told, is 200. The number of observations is 500. We'll click Next. We want a confidence interval, and we want a 90% confidence level. And then we'll hit Calculate. Now that's going to give us an upper limit of 0.436 and a lower limit of 0.364. So the interval width then will be 0.436 minus 0.364, which will be 0.072. Now half of that then, E, would just be half of that width. So we'd have 0.036. So we'll type 0.036, 0. Check our answer.